In this lesson, we are going to cover these topics: the element, the periodic table, valency number, isotopes, relative atomic number, and we are going to cover this topic, bonding. And under bonding, we will look at compounds, ionic bonds, covalent bonds, metallic bonds, and chemical formula of compounds. Then finally, we'll look at chemical formulae and equations as a whole topic. At the end, we'll go through exam questions together, and make sure to like the video so that it may reach many people out there. Many people are struggling with chemistry. And most important of all, subscribe. It helps with the algorithm. The elements. This is a continuation from my last video. I just wanted us to finish up the last part on atomic structure. If you didn't watch my last video, check it out. It's in the description. We'll start by defining an element. What is an element? An element is a pure substance that cannot be broken down further by chemical means. This is because they consist of one type of atom. You don't expect an orange out of a guava. For example, oxygen element, it consists of one type of atom, and that is the oxygen. It doesn't have any other atom. But when you look at compounds such as carbon dioxide, they have atoms of oxygen and carbon. These, they can be broken down. You can separate the carbon and the oxygen, but with an element, you can't. Each element has a chemical symbol. It is made up of either one letter or two letters. If a symbol contains one letter, it will be capital letter. If it contains two, then the second letter will be in small case. It will be a small letter. So here we can see this table. We've got names and symbols of one letter element and two letter element. Carbon is the first and it has C. The second is sulfur, which has a big letter S. That, of course, you can see that for carbon it's big letter C. With the two letter elements, we have helium, which is abbreviated as H with a small letter E because it's the second letter. And the same goes for magnesium, which has M and a small letter G. Let me put emphasis on this one. The second letter is very small. You can't find a big letter. That can't happen. If you want to prove me wrong, go and search on Google. Prove yourself wrong. Okay. Elements in our environment. Picture this. In Central and Southern Africa, chemical elements play an important role in the economic of some countries. Like, for example, in Zambia, we sell copper. We are the largest copper producing country, and copper is an element. In South Africa, there is gold and cobalt in Congo. Even diamonds are mined in South Africa. Zimbabwe, Botswana can be classified in this group because diamonds is made up entirely of carbon. Another element in the local environment. Do you know that coal is also made up of diamond? Sorry, not diamond. It's also made up of carbon. The air that we breathe contains oxygen, nitrogen, and carbon dioxide. A compound made from carbon and oxygen Among other gases, all humans, plants, and animals are carbon-based forms of life. I want you to go and search for the term carbon-based form of life so that we can know what it means. The periodic table. The elements in the periodic table are arranged according to their proton number. This is a table that shows the first 20 elements of the periodic table arranged according to their proton number. If you are wondering what the proton number is, make sure to check out the last video that I posted. The link will be in the description. And don't worry about these elements, like remembering them or taking notes or writing them. I will make a PDF and I will put everything in that PDF. I will put this periodic table and the summarized notes that I will have. For every lesson, I have a PDF that has summarized notes. So don't worry about taking notes. So these are the elements: symbol, proton number, and the nucleon number. Here's an exercise to practice what we have learned. These questions are extremely easy and I know that you can go through them. If you're having trouble, just watch the last video and you'll be able to find the answers. And if you're having challenges, don't worry, in the same PDF there will be a solution of each and every exercise that I will give in this video. So make sure to pause the video and try to solve this question. Practice makes better. So this is how a periodic table looks like. It has all these elements that you see here. And again, don't worry about writing or drawing the periodic table. I will have it in the PDF and you can just print it out. With that said, the scientists have arranged the elements of the periodic table in an increasing proton number. So it goes from the smallest proton number to the larger proton number. That's the way they are arranged. Groups. The groups are the vertical columns that each contain up to 7 elements. The elements in each group have the same number of valency electrons. We have already discussed the valency electron in the last video. Link in the description, go and check it out. So these are numbered from 1 to 8 or 0, because 8 in the periodic table can be 0. Elements in group 1, 2, 3 to 8 or 0. Yeah, so this can also be called 0. Elements in group 1, 2, 3 to 8 are called main group elements. The groups between group 2 and 3 are called transition metals. Hydrogen does not belong to any group. It's lonely. Sad. Let me give an example to this. Group 1 elements, let's pick sodium. It has 11 proton number and 23 nucleon number. So the number of electrons in the number of protons, we have learned this, the number of electrons is equal to the number of protons. So the protons will be arranged in this manner. Na, 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the outermost shell, leaving 1 valency electron. Let's try potassium. It has 9 electrons, so it will have 2 in its first shell, 8 in its second shell, 8 in its third shell, and 1 in the last shell, leaving 1 valency electron again. So all these elements in group 1 have 1 valency electron. You can try this with the other elements. Check the valency electron of the elements in column 3, 4, and 5. Periods. These are the horizontal rows that each contain between 2 and 8 electrons. They are numbered 1 to 7 and they all have the same number of shells. For example, helium and hydrogen have one number of shells. Therefore, we say they are found in period 1. Another example that I will give is of lithium and neon. They have 2 shells, therefore they are found in period 2. Hope you have understood. If you didn't, you can ask questions in the comment section below. On the periodic table, there are elements that are metals and non-metals and meteoroids. Meteoroids, these are substances that have some metallic properties. Non-metals include all gases such as oxygen, hydrogen, helium, and also solids such as carbon, and the liquid bromine. Yes, there's a liquid on the periodic table. The metals take up most of the periodic table. And don't worry about these elements, they are artificial, they are made by humans. They are not natural. They are made by humans. They're making elements. Don't worry about them. Here's an exercise. Please try to solve honestly. This is your education, not mine. I've done these exercises already. I've done them. The buildup of electrons in shells. Some shells are filled when they have 2 electrons. Not some shells. All shells. The first shell is filled up with 2 electrons. The second shell is filled up with 8 electrons. And the third will have 8, and they will just be having 8. You get the point. 2, 8, 8, 8, 8, 8, 8, 8. Noble gases. The elements in group 8 or 0 have filled their outermost shell. They are called noble gases. All elements in group 8 are called noble gases. You understand why they are called noble gases when we reach the topic bonding. The noble gas do not bond because they do not have electrons available to take part in bonding. Because if an element wants to bond, it has to have some missing electrons, or it has to have some electrons to share. But in such a case where it doesn't have, it becomes a noble gas. And you understand this clearly when we reach bonding. So naturally, noble gases are stable. They do not need electrons donated to them, and they don't need to donate electrons to other elements. They are monatomic, which means they occur naturally as single atoms. Other atoms need other atoms to be stable, but for noble gases, they are just single atoms. They don't need anyone. They are single. They don't need anyone to be stable. But other atoms need other atoms to be stable, to have full electrons. And we'll understand this when you get to bonding. Bonding is a very important topic and it should not be missed. Valency number. When an atom has full electrons in the shell, we say it's stable. For example, helium has 2 electrons. That means it's stable. And hydrogen has 1 in its shell. It is not stable because it has 1. To be stable, it has to have 2. The way I'd said 2, 8, 8, 8, 8. That's the stability. So if in the first shell it has 1, it's not stable. If in the second shell it has 5, it's not stable. It has to have 8 to be stable. I think you get it now. So let's define a valency number. The valency number of electrons any element loses or gains to form a stable structure of a noble gas is called valency number. Get this? So don't confuse them. Don't confuse valency electron and valency number. Elements that have 1 to 3 valency electrons tend to lose these electrons. And again, please don't confuse these two, valency electron and valency number. Valency electron, these are the number of electrons that are in the outermost shell, and the valency number is the number of electrons that an element loses or gains. Elements that have 4 valency electrons tend to share these electrons. Carbon, for example, has 4 valency number. It shares with other atoms. These that have 5 to 7 valency electrons tend to gain electrons to complete the noble gas configuration. Filled outermost shells, the noble gases in group 8 have 0 valency number. Electronic configuration. This is how we write electronic configuration. There's this way. Write down the number of electrons in each shell separated by a comma. E.g., sodium, it has 11 proton number and 23 nucleon number. So the electronic configuration is going to be like this. We are listing the electrons. So it will be 2, it is full, 8, it is full, and we are remaining with 1 from 11, and it will have 1. So which means sodium is not balanced. Then let's try chlorine. Chlorine has 17 electrons, 35 nucleon number. So the electronic configuration will have 2, 8, 7. It only needs 1 to gain a noble structure. And the other way we can write this electronic configuration is by drawing circles around the nucleus and using dots or crosses to indicate the electrons. Sodium has 11 electrons number. Therefore, the first shell will have 2 electrons. The second will have 8. How many electrons are remaining? We're remaining with 1, so which means this will be the valency electron. Here's an example for practice. Use the electronic configuration of sodium in the example above to determine in which group and in which period we find sodium. Also state sodium's valency number. You can pause the video and find the answer. Answers. Sodium's electronic configuration is Na281. Therefore, sodium must belong to group 1 because it has only 1 valency electron. Sodium has 3 electron shells, therefore it must belong to period 3. Its valency is 1. Here's an exercise for practice. Hey there, are you struggling with chemistry? Don't worry, we've got your back at Big Brains. Picture this, understanding chemistry without headaches. That's what you get with our tuitions. Fun lessons. Say goodbye to boring stuff. Our lessons are actually fun. Easy access. You can join us on WhatsApp anytime, no need to rush or travel far. Cheap price. Just 5 kwacha, that's it. A small price for big knowledge. Ready to make chemistry easy? Just click subscribe and join us for 5 kwacha. Trust us, it's worth it. Thanks for checking out Big Brains. We're excited to help you rock chemistry. Let's do this together.